Hello, we are in section 11-6 today. We are moving on to spheres. We are going to talk about both surface area and volume of spheres today. So hopefully by this video, you will be able to use the formulas for both of those calculations. First of all, let's talk a little bit about some vocabulary. What is a sphere? I'm sure that you could describe what it looks like, but in technical terms, or a little bit more technical terms, it is a 3D solid made of all the points that are equidistant from one single point. Now that single point that everything else is equidistant to is called the center. The center is the perfect middle of a sphere. All of the outside points of a sphere are equidistant from the center. Now the radius is going to connect the center of the sphere to the edge of the sphere. So a line, and it has tons of these. There's not just one, there's like an infinite amount basically. So a line connecting, or I guess I should say a line segment, connecting the center to the edge, for lack of a better term, of the sphere. Now, a diameter is going to go from edge to edge of the sphere, but it needs to pass through the center. So a segment passing through the center going from edge to edge of the sphere. So what that might look like if we were to draw a sphere just right here real fast, just so you could see it, we've got kind of a circle around. If we were to draw the center right here, a radius would go from the center to an edge. So this right here would be in radius. I'll put an R right there. Now a diameter would go side to side like that, okay? Now we are going to do both surface area and volume of a sphere all in one lesson today because there are not very many variables with this. So to calculate the surface area of a sphere, surface area is going to be 4 times pi times r squared, r being the radius of that sphere. The volume of a sphere, volume is equal to 4/3 pi times r cubed. All right, so let's get into this now that we know what a sphere is, what its parts are, and the two formulas that we're gonna need for today. So in this first example, we are going to be finding surface areas. It says find the surface area of the sphere, give your answer in terms of pi. Awesome. So we have surface area is equal to 4 times pi times r squared. I'm just copying that down from the formula written above. And right here, I have this 24, but that's the diameter, okay? We just need the radius. So the radius is going to go from the center to the edge. So the radius is just going to be 12 because that's half of 24. So surface area is equal to 4 times pi times 12 squared. When we do that, surface area is equal to 4 times pi times 144. 144 times 4 is 576. So the surface area is 576 pi. And then because we're working with area and inches, it's going to be square. Now, when we talk about area, the unit is squared. When we talk about volume, the unit is cubed. Just so you're aware of that. But we were doing surface area in this, so that's why we're squaring the inches. All right, so that's one example. It says, for example B, find the radius of a sphere with surface area 2,900 and 29,160. I have the comma in the wrong spot. It should be there, but okay. Anyways, we need the surface area formula because that's what we're told, but we're not going to find surface area this time because that's not what it's asking us to calculate, and we're already told that. We're going to try to find R. The only two variables here is surface area and R. 4 is not a variable and pi is not a variable. So these are the only two things that we could calculate with this formula. We're going to take this value and we're going to substitute it in for the surface area spot because that's what it's equal to. So we're going to say 29,160 pi is equal to 4 pi r squared. Now, the pi does sometimes get people confused. Because pi is on both sides, if we wanted to get rid of it, we could just divide both sides by pi, and then it's going to immediately cancel on both sides. So now we're left with 29,160 is equal to 4r squared. We're trying to solve for r. It asks us for the radius. So r is the variable. We need to isolate r. Anytime we're asked to solve, we're trying to isolate it. And the way we isolate is by getting opposite operations. So we're going to divide by 4 on both sides because we're getting that r isolated. So we're taking 29,160, dividing it by 4, and I get 7,290. Okay. That's equal to r squared. Now we need to get r the rest of the way isolated. We do not divide by 2. This is r times r. The opposite of squaring r is square rooting r. So we're going to take the square root of 7,290, and that is going to get us a bit of a messy number, but when I put it in my calculator, I'm getting about 85.34. So the radius is approximately 85.38 0.38 centimeters. Now this is just regular centimeters because we're not finding area anymore. It's just the radius, and a radius is a length. So that is just one dimension. Flipping that paper over, for this next problem, it says the Earth's equator is about 24,902 miles long. What is the approximate surface area of Earth? Round to the nearest hundredth of a mile. What's important here is we recognize that yes, we're going to calculate surface area, and surface area is equal to 4 pi r squared, but we were not given the radius, and we need the radius for our formula. We were given the equator, and we know that the equator goes around the entire center of the Earth. So this value is what's 24,902 miles, approximately, okay? Give or take a little bit. So with that being said, we were given the circumference. We don't want the circumference, we want the radius. So we're gonna have to use the circumference to calculate the radius to then find the surface area. Well, the circumference of a circle is equal to 2 pi r. Not r squared, just 2 pi r, because circumference is different than area. So if we know the circumference is this, now we can solve for r. We can divide both sides by 2 pi. And when we do that, I'm putting this into my calculator, so 24,902 divided by 2 pi is approximately 3,963.28. Okay, so I'm getting 3,963.28 is about what r is equal to. Now we needed r because the radius is the only variable in our surface area formula. So that's what we need to calculate this. So what we're gonna do now, we're gonna take this value for r that we just calculated and stick it into our formula over here. So now surface area is equal to 4 times pi and then times our r value, which is 3,963.28 squared. All right, this is absolutely going to give us a big number. I'm going to type this into my calculator. So what we've got going on here is 3,963.28 squared times 4 times pi. When we get that, a very long number. So this does say round to the nearest hundredth. I'm just going to say round to the nearest mile. I think that's going to be easier for us, especially considering how big of a number this is. So I've got 197,387,377. I'm rounding this 6 up because of that 8 right there. Awesome. And then that's going to be, we were working in miles, so square miles. All right. That's surface area of spheres. Let's talk about volume of spheres now. So volume formula is equal to 4/3, I believe it was 4/3, yeah. 4/3 pi times r cubed. All right. We know we're going to refer to that for our example 2 problems. So in example A, it says, find the volume of a sphere with diameter 76 centimeters. Give your answer in terms of pi. Once again, notice what they told us. They said the diameter is 76. So if we draw a sphere and we draw a line across, the diameter is 76 long. We only want the radius for our formula. So we need to take 76 and cut it in half, which is going to get us 38. So the diameter is 38, the radius is 38. So now we can plug that into our formula. Volume is equal to 4/3 times pi times the radius, which is 38 cubed. So we're absolutely going to want to put this into our calculators. So we have 4/3 times 38 cubed, which is going to be a little bit messy, but with a decimal, but that's okay. We're leaving this in terms of pi, so I didn't multiply the pi in there. It is 73,162.6 repeating with a pi after it. And that's going to be cubic centimeters. Okay, so we were given diameter, we needed radius, we substituted it in, used our calculator, and got this value. And it said leave it in terms of pi, so we did not multiply pi through our value. For example B, it says find the volume of the sphere around your answer to the nearest thousandths place, which will be 3 decimal spaces. All right, so with that being said, let's get to it. We know the volume is 4/3 pi r cubed, and we're given radius. It's 8, so we can go straight into substituting that in. Volume is 4/3 pi times 8 cubed. When we put that into our calculators, now there's more than one way you can do it, but this is one way you can think of it. You can type your fraction, 4/3, and then there's a bit of a glare. There we go, that's better. 4/3, and then times pi, and then times 8 cubed. Now it did say round to the nearest thousandths place, which is 3 decimals. So we have 2,144.661 because this 5 is making that 0 round up. So 2,144.661 cubic centimeters. Volume is cubic units, area is square units, and length or distance is just like a regular unit. It's just raised to the first power. All right, we have one more example. It says, what is the diameter of a sphere with a volume of 18,432 pi cubic yards. So we are calculating diameter this time. We are not calculating surface area, volume, but we were given volume. Volume, the formula is 4/3 pi r cubed. We were told the volume. So if we can figure out the radius, then we can figure out the diameter. So we're going to take this value and plug it into our volume position. So that's 18,432 pi is equal to 4/3 pi r cubed. All right. Now, pi is on both sides of the equation. Just to get it simpler, we are allowed to divide by pi on both sides, make them both cancel. We're keeping it balanced. And so now we are down to 18,432 is equal to 4/3 r cubed. What we're going to want to do now is to get rid of this fraction. There is more than one way to get rid, more than one way to think about how you're getting rid of a fraction. I'm going to multiply by the reciprocal, which means taking the fraction, flipping it upside down, and multiplying by that on both sides. So I'm literally going to say, okay, 4/3 multiply by 3/4 on the right. Multiply by 3/4 on the left, because it's this fraction flipped upside down. Now, the whole reason we're doing that is because we want it to cancel. So it cancels on the right-hand side. And then when we do that on the left-hand side, let me do that in my calculator real fast. I'm getting 13,824. So 13,824 is equal to r cubed. Now, just like when we took the square root of something to get rid of that square, actually, I think we did it just on this previous side. Yeah, notice we did not divide by 2 to get rid of this r squared. We square rooted it. Well, there is something called a cube root, and you can take a cube root. So we're asking ourselves, what multiplied by itself 3 times will get to 13,824? We're going to take the cube root of both sides to get r isolated. Now, you're more than likely going to need your calculator for that part. So the way you do that is by typing a 3, because this 3 represents that's the root you're going to do. Then you're going to hit your second key and this caret key right here. And notice the symbol above it has this little X inside of the radical symbol. That's taking care. This right here means cube root. Then you're going to enter whatever number you're taking the cube root of. So 13,824, hit equals, and we have 24. So that is telling us that 24 is equal to the radius. Now, if you wanted to double check that, then you could say 24 times 24 times 24. So that's 24 multiplied by itself 3 times. We are getting this number right here. So that's a way that you can check and make sure that you typed it into your calculator correct. So we now know that the radius is 24. However, we want the diameter. So radius is halfway across, diameter is going to be that doubled. So 48 yards is equal to the diameter. And that is our actual complete final answer. So I'll underline that just so you can see that's the actual answer. All right, so that is how you apply the volume and surface area formulas of spheres. I hope this has been helpful. Please have a great night, and I will see you soon. Bye.